Welcome to this explainer. Today, we're going to explore the invisible architecture that silently runs our entire digital world. Whenever we interact with software, we're usually just looking at the surface, right? The beautiful buttons, the sleek interfaces, the smooth animations. But beneath that surface is a massive, bustling metropolis of interconnected systems that are constantly talking to one another. And the language they use to communicate? Well, that's the API. Think about it for a second. How exactly does a travel aggregator website like Make My Trip show you all the real-time flight schedules, the prices, and the seat availabilities for an airline like Indigo? Especially since Make My Trip doesn't own a single airplane, nor do they manage Indigo's internal databases. It's a fascinating real-world utility that we take for granted literally every single day, and it is entirely powered by APIs. So in this explainer, we're going to map out exactly how this hidden ecosystem works. Our roadmap today covers 1. Sharing software functionality, 2. Reusing code across platforms, 3. The power of modular design, 4. Public versus partner APIs, 5. The web service rule, and finally 6. APIs beyond the internet. Okay, let's dive right into this. Section 1. Sharing software functionality. Let's pull on that Make My Trip thread a bit more. When you search for a flight from Hyderabad to Bangalore, the results screen instantly populates with options from Air India, AirAsia, and Indigo. Now, if Indigo didn't provide a secure way for Make My Trip to access its flight data, Make My Trip would have absolutely nothing to show you. And Indigo? They'd lose out on a massive number of potential customers. So Indigo shares its functionality by giving Make My Trip access to its APIs. Make My Trip software essentially asks Indigo's software for the flight data, and Indigo's API delivers it securely and instantly. It's literally one piece of software using the functionality of another. And honestly, this brilliantly illustrates just how interconnected our everyday apps really are. When you log into Spotify, you've probably seen that option to sign in with Google, right? Spotify doesn't want to build a whole new complex security infrastructure from scratch. Instead, they just use Google's authentication API. When you order an Uber, that map you're staring at is generated by Uber calling the Google Maps API. Or when you check out on Amazon using a UPI or your bank account, Amazon is utilizing banking APIs to process your payment. They're seamlessly integrating other companies' strengths straight into their own platforms. Which brings us nicely to Section 2, reusing code across platforms. Because APIs aren't just for talking to outside companies, they are incredibly powerful tools for saving developers from rewriting massive amounts of code from scratch. Take Microsoft's Visual Studio as a prime example here. Microsoft has different editions of this software, like the Professional Edition and the Enterprise Edition, which has way more features for large teams. When Microsoft's developers set out to build that Enterprise Edition, they didn't just start with a blank screen. No way. They took the massive codebase they had already written for the Professional Edition, exposed that existing logic via internal APIs, and then simply built the advanced enterprise features right on top of it. We see the exact same strategy when it comes to cross-platform consistency. Let's think about Amazon again. They built this massive, incredibly complex backend for their e-commerce website. But when smartphones completely took over and they desperately needed a mobile app, they didn't rebuild all their shopping cart and user account logic from the ground up. Actually, they simply created APIs for their existing web backend and had the new mobile app connect to those very same APIs. It guarantees massive time savings, cuts costs drastically, and ensures that whether you add an item to your cart on your laptop or your phone, the system behaves exactly the same way. All right, let's zoom in even closer to see what happens inside a single piece of software. Section 3, the power of modular design. So, modular design. It's really all about structuring software into distinct, self-contained modules. Think of it kind of like organizing books onto distinct, designated shelves rather than just throwing them all into a chaotic pile on the floor. Instead of having one massive, clumsy block of code that tries to do absolutely everything, developers separate the code by its specific function. And for these separate modules to actually work together as one app, they talk to each other using internal APIs. For instance, think about a digital shopping cart. The shopping cart module itself doesn't actually store all the information about, say, a laptop. It doesn't hold the price, the tech specs, or the stock levels. If it did, the code would be incredibly bloated and slow. Instead, when you click Add to Cart, the shopping cart module makes a quick internal API call over to the separate product catalog module. It basically asks, hey, what are the details for product ID 123? The catalog replies via the API, and boom, your cart updates. This brilliant setup keeps the software organized, fast, and so much easier to maintain. So, APIs are literally everywhere, but they aren't all open to just anyone. Let's shift gears to Section 4, Public versus Partner APIs. Now, what's really interesting about this is the stark contrast in access strategies. On one hand, you have public APIs, like Google Maps. Google actively wants developers to embed their maps into millions of apps, whether it's Uber, Airbnb, you name it. So they make these APIs publicly available to developers all over the globe. On the other hand, you have partner APIs. I mean, Indigo Airlines is definitely not going to just hand over its live flight and booking data to some random developer on the internet, right? They restrict their APIs exclusively to trusted business partners like MakeMyTrip or Skyscanner, establishing very specific agreements to ensure their data is used securely and properly. Up until now, almost all the examples we've talked about have relied on the internet to function. This perfectly introduces Section 5, the Web Service Rule. So the crucial point is this specific rule. All web services are APIs, but all APIs are not web services. I highly recommend locking this concept into your memory right now because it absolutely demystifies a ton of the technical jargon you often hear thrown around in the software world. To really grasp that rule, we first need to define what a web service actually is. A web service is simply a specific type of API that travels over the internet or a network using standard web protocols like HTTP or HTTPS. When MakeMyTrip talks to Indigo, that data is traveling over the internet. So that is an API, and more specifically, it is a web service. But wait, remember the second half of that rule? Not all APIs are web services. Why? Because some APIs do not need the internet to communicate at all. Consider a desktop application called Workshare Professional, which a lot of companies use to compare documents side by side. When you install it, it acts kind of like an extension, sitting right on top of Microsoft Word. When you hit the Compare button in Workshare, it communicates with MS Word to execute the task. It uses an API to do this, but because both software programs are sitting locally on the exact same computer, no data ever travels over the internet. Therefore, it is an API, but it is unequivocally not a web service. And that perfectly sets up our final layer, Section 6, APIs beyond the internet. We are peeling back the final layer of our technological onion to look at APIs that exist completely independently of the World Wide Web. We're talking about APIs operating locally on your devices right now, requiring absolutely zero Wi-Fi connection. We have local or library APIs where, say, a Python developer uses a pre-written math library to calculate a square root without having to write out the complex math logic themselves. We have operating system APIs, hardware APIs, and remote APIs, where devices might just talk over Bluetooth or local networks. Operating system or OS APIs are honestly fascinating. Think about your Windows or Mac laptop for a second. The operating system provides APIs that allow your software applications to safely interact with system-level resources. If an app wants to save a file, it doesn't just jam data directly into your hard drive. It asks the OS API to allocate the memory and write the file. When you move your physical mouse, the OS API is exactly what communicates that movement to the application you're currently using. Let's move to and see how this builds with an analogy. Imagine the operating system is a massive hotel, and your software app is a guest staying in one of the rooms. Now, if the guest wants a meal, they don't just walk down to the hotel kitchen and start cooking, right? They pick up the phone and call room service. In this scenario, room service is the API. It takes your specific request, goes to the kitchen, which represents your hardware resources, gets exactly what you need, and brings it back to you safely and efficiently. And, this logic extends all the way down to the physical hardware sitting in your pocket. When you open the camera app on your smartphone and tap the shutter button, the app itself doesn't directly yank control of the physical glass lens. Instead, Android or iOS provides a hardware API. The camera app talks to this hardware API, requesting it to adjust the focus, let in the light, and snap the photo. All of this unbelievably complex communication happens instantly, locally, and completely invisibly. So we've journeyed all the way from booking international flights on the web down to the modular design of shopping carts, past the rules of web services, and straight into the hardware sitting right in your hand. So I'll leave you with this final thought. Look at the device you're using right now to watch this explainer. Between the operating system managing your screen, the apps updating in the background, and the network keeping you connected, how many thousands of invisible APIs do you think are firing off in the background this very second, silently powering your world?